This video introduces the notion of a relation between two sets, or between a set and itself. As our first example, let's let A be the set of mountain names and B be the set of state names. Here I'm thinking of states in the United States. We could define a relation by saying for X in A and Y in B, X is related to Y if there is a mountain with name X in state Y. So, for example, Stone Mountain is related to North Carolina, and Stone Mountain is also related to Georgia, because there's a Stone Mountain in both of those states. Mount Mitchell is related to both North Carolina and to Kansas, because there's a mountain named Mount Mitchell in both of those states. The North Carolina one's just more famous. Now, Mount Mitchell is not related to California because there's no mountain in California named Mount Mitchell. We can think of the related mountain names and state names as ordered pairs. And this motivates a precise definition of relation that we'll talk about next. Let A and B be sets. A relation R between A and B is a subset of the product A cross B. In other words, R, the relation, is a subset of A cross B and consists of ordered pairs of the form AB, where little a is in A and little b is in B. We'll only be working with binary relations, which means we have ordered pairs, but it is possible to talk about trinary relations where you have ordered triples and the cross product of three sets, or n-ary relations where you have ordered n-tuples in the cross product of n sets. But we'll stick with binary relations and ordered pairs. So in our previous example, A was mountain names, B was state names, and our relation was a subset of A cross B consisting of mountain names that are in these associated state names. When we have a relation that is a subset of A cross B, then for little a in A and little b in B, we say that little a is related to little b, which we write little a r little b, or sometimes A tilde B. We say that A is related to B if the ordered pair AB is in the subset R. We say that A is not related to B, written as AR with a slash through a B, or A with a slash through the little tilde sign, if the ordered pair AB is not in the subset R. So let's define a relation between A and B if A is the set of numbers 1, 2, 3, and B is the numbers 2, 4, 6, 8. There are lots of possible ways to define a relation because any subset of A cross B defines a relation. For example, I'll let R1 be the subset consisting of the ordered pairs 1, 2, 2, 4, and 3, 6. Then we would say that 1 is related by R1 to 2. We would say that 2, there's another way of saying it's related. 2 is related to 4, but 2 is not related to 3 because the ordered pair 2, 3 is not in my relation. Here's another example of a relation between the set A, the same set A and the same set B. It's given by this collection of 4 ordered pairs. In addition to representing the relation this way, in set notation, we could represent it with arrows. This is kind of like the way we represent functions sometimes. We just write the elements of A and the elements of B, and then I'm going to put arrows between them when one of the numbers on the left is related to one of the numbers on the right. So 1 is related to 2, 1 is related to 6, 3 is related to 6, and 3 is related to 8. We could also represent the relation as a table of values. where we simply write the ordered pairs in a table, like this. Or we could write it as a table of values in another way. Here, the elements of A index the rows of my table, and the elements of B index the columns. And I'm going to put an X in the table if the number A and the number B for the row and column are in the relation. So 1, 2 is in my relation, 1, 6 is in my relation, 3, 6 is in my relation, and 3, 8 is in my relation. I could also represent my relation as a graph in the xy plane. Here I'm going to put the numbers from A along the x-axis and the numbers from B along the y-axis. And I'll simply put a dot on the xy plane for each ordered pair that's in my relation. Finally, I can represent my relation as a matrix. This representation is similar to the table representation here, except instead of x's, I'm going to put ones and zeros. As with the table, my rows are going to correspond to elements of A, and my columns are going to correspond to elements of B, and I put a 1 if the corresponding ordered pair is in my relation, and 0 if the corresponding ordered pair is not. So far, we've been talking about relations between two sets, but you can also talk about a relation on a set, which means a relation between A and itself, i.e., a subset of A cross A. So for example, if W is the set of letters X, Y, Z, then a relation on W, this relation is given by this subset of W cross W. We can represent this relation like we did before by using 2 copies of W and drawing an arrow from the copy on the left to the copy on the right if the ordered pair is in our relation. So we need an arrow from X to X, an arrow from X to Z, an arrow from Y to Z, and an arrow from Z to Y. But we could also draw the relation just using 1 copy of W. So I'll space out the letters in W a little bit differently here to make more space and make the picture look better. Now I'm going to represent the ordered pair XX with an arrow from X to itself. I'll represent the ordered pair XZ with an arrow from X to Z. YZ means I have an arrow from Y to Z, and ZY means I have an arrow back from Z to Y. In this video, we talked about relations and how to represent them as sets of ordered pairs, as tables, as graphs, matrices, and arrow diagrams, which are also called graphs.